All right, so we're running again. With that in mind, our next presenter is Smart Rider. Smart Rider, are you here? I know you're here because you responded.
Yeah,
Do you want me to? And I was trying to figure out, by the way, when I was doing this thermometer thing, I was trying to remember what the link between observatory and thermometer was. And I just couldn't come up with one. Telescope makes a lot more sense. Do you want me to present, or do you want to present? How do you want to do this?
I can share screen.
All right.
Yeah. All right, I'll start with that.
So I will go to Webex. And I will transition that over, and now we should get funky for a few minutes. And then I'm going to go in and...
Is that visible?
Not exactly yet. Give me just a second here. It is visible. It's coming up. I just need to remove myself, and you came up faster than I could get rid of the... It's funky on this end. There's a thing that says you're sharing your screen, or you're syncing your stage view that gets presented, and the problem is it goes right over the button I need to press when there's two screens on here.
I can stop sharing if you need it.
Oh, awesome.
Yeah,
it goes right over the button I need to press to say, don't show my screen. Okay, we're good. We're good now. If you present,
right,
you
cool.
should be good.
Yeah.
And I am going to use this opportunity to sneak to the back, or at least sneak a little further back so I can watch the presentation and take some notes.
All right. I hope my Webex is lagging. Hello?
Yeah, we're here.
Okay. All right, so can you see the top part? There's like a black bar on my screen now.
Right now we're just seeing Joseph Ethan is starting to share content. We're not actually seeing your screen yet.
Okay, I might have to restart Webex. Give me a second.
Okay.
All right, let me try this now.
There.
Okay, cool.
You're good now.
All right, so we are Smart Rider, the all-in-one RPI transportation app. I'm the project manager, Ethan. And then this semester, also worked on by Dee, Alex, and Mike. So Smart Rider is basically our goal is to be the all-in-one RPI transportation app. We want to allow for you to easily call a safe ride, sort of like an Uber. Also interact with bus and shuttle schedules. Then we have a real-time map with live shuttle and bus updates. And you can also see all of those routes on the map. And our overall goal is to make the travel around RPI safer and easier.
So this semester we made some significant progress continuing the project. There's a lot of updates with Flutter and Dart, so we migrated to them. Specifically no safe Dart, which required us to change around a lot of code, or we did null checking ourselves. The repo, we flattened it to one branch to make development easier. So we split the Smart Rider app into two apps, one for the drivers and one for the riders. And the driver's app is a simple little app that is pretty much done, has a location tracking, and it serves its purpose. We started a web mode, so you can open the Smart Rider on the web if the app isn't working for some reason, or if you only have a laptop. The bus delay updates are now real time using CDTA data. The map legend was reworked. It's more animated and forward looking. We worked on the UI updates with resizing the app, making sure everything fits correctly. On the back end, we added some crash lyrics. So it is a library that basically gives a crash report every time the app has some trouble and crashes. we have phone verification for smart writer users, so that you need to have your phone verified before you call it a safe write. We set up a Docker built environment for every instance of Docker, or for every instance of the app to be the same. And then safe write weight estimates, we implemented an algorithm for that using exponential averaging.
Okay, so I want to briefly go over the tech stack that we're using. So for front end, we're using Flutter, which allows us to convert our code to basically either iOS, Android, or web app. It's very flexible. And for backend, we're using Firebase, which is very easy to use, but also very powerful database management tools. And it allows us to create backend functions that are called cloud functions that can make database management very easy. And also, obviously, since we're a transportation app, for our backend, we're also using Google Maps and Places API, which is a very powerful mapping tools.
Yeah, so one of the main features we worked on over the summer was the drivers app and sort of fleshing out the safe ride functionality. So we have a separate drivers app. It's sort of bare bones UI at the moment, but it allows like drivers can see the next available rider, and then also there's links to open a Google Maps page, to their pickup and drop off locations. Additionally, users call a safe ride and see queue positions and wait times through the smart rider part of the app. Here's like a UI example of what that looks like. We also implemented a map switching and legend. Since we do have kind of three different transportation services that we support, we need some way to switch between them, because if we were all displaying them on the same map, it would be very crowded. So users can switch between doing bus routes, shuttle routes, or safe ride locations through this expandable action button on the side. Then there's also a legend that explains, the different icons on the map.
Alright, so dynamic resizing was also implemented. So no matter what the device is, the pages in the app will adapt accordingly to the dimensions of the screen. So no matter what the display is, it will be proportioned correctly and it will look practically the same on every device.
So before you have to call safe ride, you have to verify your phone number, and the database we use, Firebase, has a built-in library to handle this. Simply you enter your phone number, it sends you a text message with the code, and you put that in your phone verified.
Okay, so this semester I worked on bus arrival time and also safe ride time estimation. So so our bus arrival time now uses the real-time data provided by CDTA, so it's more accurate compared to before, where we're only using the timetable. And also the safe ride arrival time estimation has been reworked using exponential averaging. So it puts more emphasis on more recent data, which is what we want.
Alright, so we also included a Docker build environment. So practically on any machine, the application will run in the same environment. And because of this, there won't be any discrepancies between how it performs in any device, because all the packages and dependencies are included, and then there won't be any features that are missing. Everything will be the same no matter what the device is, either smartphone, tablet, or computer.
So for the GitHub and developer side of this, we extensively use the issues on GitHub. Pretty much every task was given an issue assigned to a team member, and then we commented on it. We resolved it with a linked commit when it was done, and each issue had tags. It was just high priority, the usual stuff. All communication was in Discord. with messaging, and we had voice communication mostly after RCOS meetings. For new members, there is a build guide and documentation on the repository with the link to GitHub pages that has all this information. And before we started working, we had truck-based development. So we put it into one branch because what it was like before, we had many branches and it was a lot of effort to merge them smoothly. So this way kept everything smooth.
Right, so we're at that stage in our development where we could actually open the beta and release, which is one of the bigger goals for the next semester, so we're really hopeful for that. Along with that, of course, we're gonna have continuous integration, finishing up the unit tests and setting up CI. That way, once released to the public, it will be ready, and hopefully there won't be too many issues upon release. Another big part of the app, of course, as said before, is the safe route feature. That way, students could have that ability, that accessibility to go around campus, and we want to incorporate that. And by next semester, we plan on meeting with the student life and the safe route team, and hopefully incorporate it and make it run smoothly. And lastly, I want to include the alert system, which is just a quick system for sending alerts out from the back end. And these mainly are our main goals for the next semester.
And yeah, so here are sort of what we worked on and links to our commits. And thanks for listening. So we'll take any questions either now or in the chat later if you have any.
All right, do you have any questions online?
Yeah, I have a question, just for my own personal interest. When you're, I don't think I heard you mention this, when you go about, when someone enters into your, say, queue to become a rider, how is, for a given driver, how do they see the list of unclaimed people? Is it based on like recency that they were added, or how far away they are? How does that work?
Yeah, it's all based on recency.
Okay.
Yeah, because we're trying to emulate the translog system, which was also just sort of like a queue. It didn't really factor in distance. So that's sort of the system that we're working towards.
Okay, sure, that makes a lot of sense.
Anybody else? Go all the way back to one of your first slides. You were talking about the enumeration of all the things you got done. Like maybe slide 3 or 4.
I'm sorry. Can I hear you?
Sorry, I'm muffled and I'm away from the microphone. Could you go back to Could you go back to like slide 3 or 4? There, that
slide.
one down. I do like that though. One more. You had one where you had where it had all the list of all the things you guys had done. It had Crashlytics on it. Okay. If you're doing a safe ride project, do you think you maybe should put code Crashlytics on that?
Code Crashlytics?
As opposed to I mean, hopefully you're not having so many crashes of the safe ride transportation that you're doing a lot of NTSB analysis of it, right?
Oh no, yeah, this is more just in case, and then we also manually send like logs and reports to the Crashlytics. Is more so just a service, like just in case there's a random crash or.
But this is a crash of your software, right? Not a crash of your cars.
No, yeah, just the app.
Yeah, let's put code Crashlytics on
Not
there.
necessarily for the driver app, just for the riders.
Yeah. Okay. Now I was just caught because I'm sitting here thinking, wow, you don't put a review type system until you've had a crash. So it looked to me at first like you guys were crashing a lot of cars.
Yeah, no, that's definitely not the goal.
Okay, good. I do like the fact that you guys are paying some attention to CI, continuous integration, continuous testing. So good job. Any other questions for them? Yes. Yeah. So you're getting lots of kudos. on the style. The presentation, actually, and I think that's a true statement. The presentation kind of has a nice, interesting look that does help. So good job.
Great. Glad you
Okay.
liked it.
I couldn't find a way to phrase it into a question, but you're right. That was a good comment. All right, BrokerBot, do we have you guys?
Yes.
Are you going to share your screen, or do you want me to?
We are here.
We got it. We can share our screen.
Okay, and I will go back and sit down again and put my mask back on.
Okay. Cool. All right, can everybody see properly?
Yeah.
Yeah, all good? Word. Hi, so this is BrokerBot. It's led by myself, and the team includes Ethan Tuttle, Shantini, Joe, and Sheldon over here. The BrokerBot is an algorithmic trading engine and investment portfolio manager that allows users to run and test their own algorithmic trading strategies, and as well as manage their overall portfolio. The idea behind it is to incorporate trading strategies as a part of normal portfolio management rather than keeping it completely separate. So this is our,
Yeah, I get it. So despite a lot of hardships this semester, we made a lot of good progress. The front end looks amazing now compared to what it was from the semester prior. A lot of details have been added. We've added a lot of testing scripts because you can't have any errors in a program that's dealing with people's money. So almost every single bug possible needs to be tested for and fixed. So that's what these testing scripts are for. And the back API and the database were set up, which is a critical part of the whole program. So 3 really big things were done this semester.
So for the stack on the front end side, we used React and Redux as well as Django with Alpaca API, and we set up our database using PostgreSQL. For the back end, we used Python and a multi-processing library, Alpaca API, and Backtrader.
Our goals this semester were to fully debug the backend, to build out a full front end, design a portfolio tracker, as well as write tests for the front end. We were able to accomplish writing the front end and designing it as a portfolio tracker. We also were able to create user databases, adapted a Django web app framework to it, as well as write test scripts to the front end. However, there are still some bugs at the back end since it is very complicated.
Hello, I'm Sheldon Jackson, and this semester I worked on creating a different application for this project. We used React to make this project, and my main emphasis of the semester was found in the login page and tester page, creating a dashboard and working on a graph for the portfolio. And on this slide, you can see the login page on the top right and the dashboard shown below on the bottom left.
So I'm going to stay on this page while I go into mine. So what I helped to do was I assisted Sheldon a lot in actually designing this front end out, and since I serve as both the project manager and the customer in a sense, I helped design the front end, wrote the majority of it as well. I also worked on debugging the backend algorithmic trader. This was significantly complicated since we use a lot of multiprocessing in it, which causes a lot of errors with interweaving. So that was just been really annoying to try and debug because they change every single time. So we're still working on debugging the backend properly, but we have made some significant progress this semester. I wrote some testing scripts for the routing functions from the front end to the back end, as well as some Selenium scripts for the front end.
My name is Ethan Tuttle. This semester I worked largely on the routes for the API for BrokerBot. This semester we added things like user login and registration, also front-end routes for bot or database reads for the bot. You go to the next one. Also worked on encryption for the database. It was based on the TBKDF2 hashing algorithm, which uses random salts each time you encrypt a new thing. And these encryptions don't get, there's no like decryption key. And the way you check to see if a password passed in is the same as a encrypted password stored in the database is by taking the salt that you originally hashed the password with and rehashing the new password you're trying to check with. And if both of the password, if the new password is hashes to the same as the stored encryption password in the database, then you know it's the same. And I learned a lot about encryption this semester, and I thought it was really interesting.
Hi, I'm Joe Poppin, and so this semester I did a lot of debugging in the back end. You know, there's a lot of bugs in there, and that's really complicated. But a really big thing I like to do this semester was create the testing script in Selenium, because it's a really awesome framework in Python and any other language. And it can be used for simply just testing web pages, or even it can be used for credential checkings for hackers. It's a really, really powerful framework. And so you can test it on all sorts of different browsers, and it gives you a good idea of whether or not a user will have a good experience and how many bugs they'll run into along the way. So.
Over the course of the summer, I worked to create the database connection for BrokerBot using PostgreSQL. Within our schema, I created a bots table to hold bots ID, the user was linked with, and the bots alpaca key. I also created a users table to hold the username, ID, and password information. This data was collected from the register route and allowed users to log in through the login route that Ethan created. Next slide. So the code first started as raw SQL queries, and then I worked on writing code so that they could be run through Python. So I first created a class to handle connecting to the database and creating tables. And then for each of the tables, I created a class that specified the database fields, and within the class, different functions to carry out specific queries. For example, the user and bots classes have functions to insert data to the respective tables. The user functions were then implemented in the Django routes that Ethan created. The login route found if a user existed within the user table, and the register route found if there was a user with the same password or username, and if there wasn't, ran the function to insert the user's information to the database.
For this project's documentation or organization, we have a short reading file for the project description, visual aid for the project structure, and comprehensive specifications for each function in class, allowing for easy navigation of the code base. We also have a Trello for task management, so we assign tasks to the Trello, and then everyone will work on their specific cards.
So our future plans are to implement a Cerebro back trader for it, so that users can back trade their strategies against previous historical stock data. Implement Binance APIs to connect to crypto exchanges. We need to tweak our web app framework a little bit, especially in implementing more routes. Need to begin paper trading strategies, another feature for the end users so that they can trade with fake money to ensure that their strategies won't just lose everything as soon as they go live. And we need to begin hosting on Docker and Heroku moving forward. Any questions?
Any questions online?
I couldn't hear that.
I'm moving. Any questions online? All right, what about here in the room among our stalwart 5? All right, so here's one. So I want to go back to what was I thinking about? Well, the first thing I want to talk about, you guys are using Trello, right?
Yeah.
Is there a reason why you chose to use Trello over something that was better connected to the database? I mean, or to the repository? Because right now, if you had an external person coming in, would they have access to Trello?
Yeah.
Would they be able to?
Trello's public, so yeah.
Okay.
And Trello at the moment, we used it because it was very easy to assign tasks. So we use like several different boards for the different like main infrastructure of the bot. So like you got a lot for the back end, you got some for like the specific page development on the front end, some for the like Django back end, and you can as well have people like take on like, their exact cards that they want. And we found that that structure was much easier to like administer tasks to everyone through, as well as it was kind of a legacy from last semester where we began using it.
Cool. And one more. This is kind of similar, I guess. You had the scripts. You were doing test scripts. Is that integrated with the repository? So like somebody who's just downloads your repository and wants to run your tests, is that something that they can do, or?
Well, that's up to Joe right now. So, Joe, do you want to answer that? I don't believe so. But
We actually just created an installation guide the other day. So if you wanted to run the testing scripts, you could.
Okay. So they're in the repository. They're just not well documented. Is that?
The testing scripts are not well documented. No. They really were meant for internal use only. But I mean, if you understand Selenium, you can just. Selenium is a very I don't know how to phrase it. If you know it, you know it, and it's easy to read. And so I'm sure if you took a peek, you'd understand what was going on and how to implement them.
Yeah, no, I'm just, because that's actually something, that's really useful. So for example, Selenium, correct me if I'm wrong, is that the screen position testing? So go to this position and click.
Basically, you can program a person using the browser.
Right.
So they can refresh the page, you can change tab, as web drivers. And it's used a lot in crime, making credential checkers on websites, like brute forcing Facebook or something like that.
Yep.
But it's also really great for seeing how a user will be able to use your website and finding those bugs. So.
Right, but it's based off of controlling the cursor and clicking, or is it based off?
Yeah. I can hard code positions, or I can,
Right.
You can choose where the cursor goes and what forms you want to type in, keystrokes, all that.
So one of the things about it is it's very susceptible to issues with screen size.
Mm-hmm.
So I've actually used it. So making it public. Mine actually help you guys with layout and things like that as people get different size screens. Some people using it on a laptop, some on a widescreen monitor, et cetera. So it may help you kind of, it would at least be able to provide you feedback with usability on different size screens if you made something like that public and robust enough to be actually useful. Anyway.
Yeah.
Anyway, I just wanted to throw that out, that was, it's always good to have your testing available.
We always welcome a great idea. All right. Well,
all right, good job. Good job, guys. Let's give them another round.
All right, yeah. So I got to keep my audio on for Sheldon because it is,
my mic is very awful for a while, so I'm just very talking.
Yeah, so I'm just going to hang out here.
And
Cool.
Can you share the slides with temperature?
I'm sorry?
Can you share the slides with temperature? I put them in the slides channel.
Oh, yeah. I'm sorry. Oh, this is a different project. Yeah.
Here, send me them and I can just put them up for you.
Yeah, just go to slide channel on Discord.
Sure.
I'm sorry, I wasn't quite grabbing what you were saying for a minute.
We're grabbing more slides right now. I'll be in 1 minute. Yeah.
I forgot that Sheldon was doing multitasking.
Yeah, I wasn't sure if I was supposed to present for both, so I just kind of went.
No, it's good. All right, so you're going to do temperature now, too?
Yeah, well, give him 1 second. I need to...
Are you solo on temperature? Sheldon, were you the only one on temperature?
Me and Jay worked on it this semester, so just us two.
Okay, so Jay is going to present with you on this, or does he have separate slides?
Jay has some slides on the same presentation.
Okay, good. And I'm going to go back. I'm just figuring out whether I can stay there or whether I can. Yep, you're coming through loud and clear.
Okay.
Okay? I'm gonna go sit down and I'll turn it over to you guys now.
Yeah, so this semester, me and Jay worked on Temperature, which is a Spotify music recommendation system of the future. So once again, the project manager was me and Jay worked on the back end. So what exactly is Temperature? Temperature is a application that is gonna make it so that users are able to correlate their listening habits with the weather. To the right, you can see what our stack looks like and our semester goals for cleaning up the project and making it easy for new members. As in previous semesters, we kind of rushed through the design process and it wasn't easy for new contributors to come into the project. So we wanted to slow it down and really focus on that this semester. As well as we started making the UI and theme for the application as well. So for the project organization, we have a separate GitHub repository for each major part of the application, and we have auto deploy on Heroku through GitHub. Each member of Temperature works in a specified area, and we use GitHub project tabs to try and keep the project as organized as possible. For the project stack, we use React with Redux, which is JavaScript, Flask, which is backend in Python, which connects to a Spotify API and weather API, Heroku and Microsoft Azure for the hosting, and the database is Azure SQL and a Redis app. For this semester, I'm going to be working on the front end, and my projects for the semester were cleaning up the front end repository, working on making the application more easy for new contributors, designing a new login page, and creating the overlay for the application, and starting the dashboard UI. So as you can see here, this is the design I went for the login screen for the application. I added a thermometer on the right side, and I'm not sure what I'm going to have it incorporate now, but it's going to keep track of users, playlist made, song made, or some type of data like that. Here we can see the dashboard page for the application. So this is going to be the main dashboard you see when you log in, and then the graph is going to represent date, or it's going to represent types of weather. So the ABCD is going to be replaced with types of weather, and then the colors are going to represent what type of music you listen to on that day. So like maybe on a sunny day, I listen to 30% rap, but on a rainy day, I listen to like 45% soul. So it would show that type of thing.
Right. So I worked on the back end part. When I first joined the project, no one else really was working on it. So and the back end has much more done compared to the front end. So the others who had worked on this in previous semesters had done this without too much documentation, which caused a lot of problem for me. To catch up a lot of things on my own and cover. Say one of the biggest blockers I had encountered was that nobody was really there to help me or to answer any questions I had. So, I worked on this on my own. So in the first days of the semester, I started going over the code myself, and then realized that many of the things needed testing code to test them and see if they're working fine. So I worked on generating test code throughout the semester so that can work on some new features in the coming semester with what we have now. For the testing, nothing fancy has been done using a scheduler or any of the continuous testing. I did everything sort of manually using Python, Flask, and Unix scripts. But now with some of the test codes, I understand how some of the functions work, and also make sure that they work fine, so they pass the tests and whatnot. Luckily, I didn't find much bugs on the back end. Yeah. And the part in the red box is the directories I've worked on.
For the current state of Temperature, it's still not a fully functional web application, but we sure are getting closer to our final goal of having a beta. The front end is nearing completion, but still needs work switching, as we're switching the hosting from Heroku to Microsoft Azure, because it just works better for our project with the machine learning. And We also need to create the machine learning algorithm for predicting playlists, as well as finishing up the testing that Jay started this semester for the back end and hopefully making it continuous testing so that we can always check it. For the future of temperature, we're going to develop a temporary algorithm to create playlists for users. This way we can get the data out faster as we're making the main way of making an algorithm for users. We're going to create and train the machine learning model as we collect data to train the model. We're going to finish the front end UI and start connecting it to back end routes. And we're going to put in more installation guides into the README so we can help hopefully contributors make their commits. Any questions?
All right, do we have any questions for the temperature guys? Which one of you wants to go for either one of you? Nia can go first.
How does this compare to similar services like Last.fm?
Did you hear that? How does this compare to similar services like Last.fm?
How does this compare to similar services like Last.fm? So we're both music recommendation systems, but temperature is primarily focusing on the weather aspect and seeing how we can generate music for users based on the weather that they listen to music on certain days. So it would be similar, but we think it'll provide different results due to the weather aspect.
Right, and that leads to one of the problems that we found during this semester, and while we were discussing about the pipeline and everything of machine learning, was that if you live in a certain area where the weather is kind of is stable, then there isn't much correlation between the weather, and there wouldn't be much correlation between how the weather is like and the music you're listening to. But if you live in, let's say, Troy, where some days it's raining, some days it's sunny, there might be a correlation there that you can find. So, everything's based on the weather. We're trying to look at people listen to a certain type of music or certain genre of music and make recommendations based on that.
Go ahead.
Yeah, so you touched on this a little bit, but for example, I'm going off to vacation in Puerto Rico, and as you can imagine, if I'm listening to music in Puerto Rico, one day it's going to be hot and humid, and the next day it's going to be hot and humid, and the next day it's going to be hot and humid. So, and my music, I could listen to any music. Who knows what music I'll listen to? So, I was actually curious. You touched on this a little bit about how the weather in certain locations it might not change. So I was actually wondering, are you using any sort of deviation from your typical climate in the area, or are you just looking at the
So I'll try to paraphrase it. Otherwise, you can also come up and speak into the big mic.
So yeah, my question was related to the climate in areas where the climate just doesn't vary too much from day to day. So are you strictly using the weather alone without looking at the average climate and the variance of the climate in a certain area? Or are you actually taking a look at the deviation from the norms? So in a place like the Bahamas, it might always be just hot and humid, and maybe you may need to look into, the weather was off by 5 degrees today, and this is way off of the norm, and this is the music change. So I was wondering how much you look at climate versus climate in the average climate in that zone.
Yeah, so like you're saying, depending on where you live, the algorithm is going to work differently. As if you're in Troy, a 5-degree temperature difference isn't really a big deal, versus if you're like in somewhere like the Bahamas, a 5-degree temperature difference can be a lot bigger deal because the temperature is very less. So the algorithm is going to incorporate, it's going to take into location probably how close you are to the equator with longitude and latitude, and then have a certain algorithm based on that. And we don't only strictly use weather. We also use we're going to be using an algorithm kind of like how Netflix recommends movies to people, but with music. And we're going to use that to give our users music. So it's going to be that combined with the weather. So we're hoping if we combine where you're at on the Earth plus an actual recommendation system for music, that will get good results. If that answers the question.
All right. I think I'm just going to throw out. Have you guys started using it yourself? Even if you're not getting a weather-based recommendation, just to test out the rest of it?
We don't have the recommendation system to a point where we can start using it ourselves, but we have started to incorporate just giving ourselves Spotify songs through the code instead of just like actually looking up a song because we can add songs into our own Spotify's given that we have our Spotify API key.
Okay. Yeah, that's kind of a little bit of what I was talking about. Is just starting to use the system to make sure that all the different parts of it work together. Cool. Nice. Any other questions? Let's give them another hand. I think Pi Clarion, you're next. Is that true?
Yeah, we are here.
Do you want me to present or do you want to present?
I think Joe, are you here? Can you present for us?
Yeah, I can present.
Okay. And I will head back to my other computer where I'm taking notes, and you guys can go hold forth whenever you're ready.
Okay, is it presenting?
Yeah, I can hear.
Yep.
Okay. Hello, I'm Joe Chu, and I worked on Python this semester.
Oh, by the way, you're not like zooming into the
Okay,
slide.
yeah, it's the wrong one. How's that?
Yep, that looks better.
Okay. Hello, I'm Joe Chu, and I worked on Python this semester.
Hi, I'm saying I'm also working on Clarion this semester.
PyClarion is a rendition of Clarion in Python for learning and experimentation. And Clarion is a cognitive architecture incorporating both neural networks and symbolic representations. It's kind of like a simulated brain, but much more abstract. And you can think of it as a network of neural networks with some extra bells and whistles.
And the theme of this semester is mainly on bug control. In specific, we focus on testing and debugging the feature domain, and also testing and extending the NumPix library. In terms of how to contribute, please check out the GitHub repository. The README gives a good overview of the library, and the contributing file also gives some additional information. And current contribution process is really simple. Just talk with the maintainer, fork code, and submit PR. So what I did for this semester is mainly testing and debugging component classes in Pyclarion library. The first class I did is domain, which defines a set of feature symbols used in the simulation. Domain can be viewed as a collection of features. For example, if a travel agent is simulated, part of the domain could be the user-defined locations. But anyway, I focused on testing the key functions of domain, such as testing if the class recognizes overlaps between other domain objects, or only calls certain functions when necessary to reduce overhead. One thing to note that we found new functionalities of unit test useful, which is mock objects. For instance, we have a class variable config, which directly associates with the class domain, and we don't want to take risks changing it during testing. So what we did instead is to use the mock object to simulate the domain class, and that mimics the behavior of a real domain in controlled ways, without the need to worry about its dependencies. And one thing worth noting is that during testing, we found certain shortcomings of the domain class. Like some class variables are not named in a very intuitive way, or other variables stay unused in the domain but got utilized in the subclasses, which cause trouble understanding the code. So I also made effort in adding docstrings to the class domain. And one last thing, the testing for interface is completed as well, which interface is a class of is a subclass of domain. Interface is defines a symbol to choose action and allow agent to select the action. The key functions parse command in interface is heavily tested, and which assures the result we got is correct for the processing. At last, for all testing mentioned, several trivial cases did give me surprise results, such as overlap detection acting well in important cases. All bugs found are reported and fixed accordingly. And yeah, that's what I did for the summer semester.
I worked on numdicks and unit testing numdicks for this semester and last semester. Numdicks are numerical dictionaries that allow for automatic differentiation, which is helpful in training neural networks. This allows the user to perform a sequence of operations within a gradient tape, which records the operations performed and differentiates a given provided numdict with respect to the requested variable as specified in the gradient function. In the example shown, tape is the gradient tape used to record the operations. Result is the numdict used to store the operations being performed, and the zeroth index of grads is the numdict representing the derivative of result with respect to the variable x. Last semester, I worked on testing arithmetic operations and verifying that their autodifferentiation functioned as expected. I worked on most of the basic operations like addition, multiplication, power, division, and logs. This semester, I worked on more advanced functions like on the right, where some function takes in a numdict and returns a modified numdict, sometimes with extra parameters. As of now, there exist some methods which we call functions, which when called during a tape do not support autodifferentiation. My goal this semester was to reduce the number of functions and increase the number of methods that support autodifferentiation, otherwise called operations. Autodifferentiation requires some mathematical analysis because some of the functions are not intuitively differentiable, like addition or other arithmetic operations. To determine the desired value to be autodifferentiated, it's easiest to try and plot the effects of the functions out. For example, we use the operation threshold with a parameter of 3, which returns a numdict with values of above 3 set to 3. The initial numdict on the left would be transformed to the numdict on the right. Every f of x value above 3 would be autodifferentiated to 0, and every value below 3 would be what it initially was, or 1. Note that the initial numdict may not be so simple. The next step would be to test the operations for their expected outputs. There were various functions which had bugs that were fixed and had undesired outputs. I also wrote unit testing that verified that the operations behaved appropriately with various numdicts in various states, as well as that they performed as expected before or after other operations. I have finished converting functions to operations such as keep or drop, which keep or drop certain values in numdicts, as well as functions such as threshold and clip that set numdict values based on parameters. I'm in the process of converting Boltzmann, which is a statistical distribution function, to an operation. Thank you. Do you have any questions?
Any questions? All right, do we have anybody in the great ether with questions? So, I guess my question is, this is working, if I'm not mistaken, this is being applied to your mentor's PhD studies. How is he finding this useful? Are you guys making progress for him?
I mean, I can speak to that, unless you guys want to speak to it. Yeah, I think so. especially catching the bugs and fixing them. It's very reassuring.
Yeah. I really like that there's a focus this semester on you know, some of the, I think you've been working on testing all along, but I think that that's been, you know, been one of the things that I really like, and I'm seeing it in a lot of the projects this summer, that there's been a lot of effort put into actually testing things and pulling out bugs and reporting them and fixing them. So, was that driven from the top or from the bottom? You know, was this a top-down edict, or was it a bottom-up kind of organic growth?
It was a little bit of both. I mean, I thought testing, like, I thought the library was at a point where, you know, for a while where there needed to be testing because it was just too big. But I also think it was a lot easier to sort of, like, work through testing because it, you know, it allowed people to get familiar with the different pieces of the library, and then once they got a hang of that, they could just sort of go on and build on top of that, and then test that, and so on and so forth. So it was a bit of both, I think.
Yeah. Well, it's funny that testing is both a big help for people coming onto the project, and is generally a low-hanging fruit that people just coming onto the project can contribute to. It's kind of weird that way. But I think you're right. I think that's a useful aspect of it, and it's really good to have some people focusing on it. All right, let's give them one more round of applause. I think that brings us to telescope then, and not thermometer. How do you want to do this, Nia? Okay. So Nia's been working on this for probably more semesters than she wants to have been working on it, but we're making great progress. There you go. You are large and in charge. Oops, I'm sorry. You're not large and in charge yet. I did not swap over the much of anything, in fact. Okay, so that is now going there. So why is that still not going? Ah, I know. Because I am up here. Now we're good. It was really nice of everybody to go all in a row with the same type of presentation. I only had to figure this out once.
Okay. I'm Nia. This is my presentation here on the state of RCOS infrastructure, which is mostly telescope. Oh, how do I think I'm in the wrong window here.
Yeah, it's probably that is my fault, but that is what is the problem.
There we go. Perfect. Okay, so the team is just me. This is my 8th semester in RCOS, 3rd semester as a coordinator, 7th semester mentoring. I'm the telescope project manager, full stack dev. I maintain the database and API. Here's my contact info. I'm sure everyone here knows me already. So RCOS infrastructure uses a 3-pronged approach. We have telescope itself, and then below it we have the RCOS database and API. And then we also have the RCOS handbook, which just hosts documentation and information about RCOS as an organization. All of our code for all of that is on GitHub under an MIT license. Public projects, including Telescope and the handbook, have issue templates to make it easier for users to report bugs and stuff. All the repositories have a README. All of them have a documentation on how to build and contribute. So we try to make sure that people have a good experience interacting with our projects, even if they're not interacting directly, if they're just seeing them on GitHub or whatever. So the database and API tries to solve the problem of where do we store data for the membership of RCOS. Currently, we have a variety of platforms and service. We have Venue, Discord, Google Forms, Google Sheets, Observatory, Submittee, GitHub, SIS. It's a lot to deal with. And so the database is an attempt to bring that all together, or at least a lot of it together, and store and own that data, take ownership of that data as an organization. The highest priority of this database is longevity. We want it to last. We don't want to make a new database, get a bunch of student data in there, and then, forget it exists. That wouldn't be great. So that's why we've made an effort to separate the database from Telescope and the handbook and other parts of RCOS infrastructure, so that if Telescope or the handbook falls by the wayside or gets forgotten, the database will not. So we've got the original design of the database linked here, and I've also linked the database workshop that Frank gave last semester in case you're interested. The API that runs on top of the database is automatically generated using Hasura. It's a GraphQL API, so it's very modern and very useful. The database itself is Postgres, and we run that in DigitalOcean. Everything's hosted in a Docker container, which is then hosted in a droplet. And so it's pretty convenient and pretty easy to manage. And all of our different Docker containers run together using Docker Compose. We have automatic TLS or SSL support using Caddy as a reverse proxy, and that also runs in our Docker Compose. The handbook is not a new idea. It's actually existed for 3 years or so, almost 4 now. The purpose of the handbook is to document the standards and guidelines of RCOS. We write the entire handbook in Markdown, so it's not super complicated. There's no coding involved, and all of the Markdown exists at this GitHub repository. In the future, we hope to migrate the handbook to a more advanced and interactive wiki-style experience. And so eventually we will migrate it to wiki.arcos.io. That hasn't really happened yet, and that's something that Steven is working on, but I think he graduated, so we're figuring out exactly where that's going. So Telescope, the part that I worked on, for the most part, I also worked on the database. That's why I included it, and so the handbook as well. But Telescope is the meat of the RCOS infrastructure. It's the next front end. It will serve a website to browse the data stored in the database. And also now it has a Discord bot, which is super useful. The database doesn't deal in authentication itself, so except for authenticating with the database itself with admin credentials. So Telescope does all of that, and then will make interactions with the database on the behalf of RCOS users and other viewers of the website. And we authenticate users using GitHub or Discord or RPI-Cas, and perhaps eventually other services. So Telescope's in its 4th semester of development, 4th straight semester of development. Yeah, that would be because summer, fall, spring, summer. So yeah. So we passed 1,000 commits this semester, so that's pretty exciting. There was a bunch of stuff added. The, I think, largest feature was the ability to create, edit, and delete meetings in the Telescope interface, and access to do that has already been given to both myself and the other coordinator, Hunter. So we've been using that this semester, actually, to, every every meeting we've had, including the presentations, including this RCOS meeting, exists on Telescope already. So that's awesome. That's great news. I also introduced an interface to add and edit semester records so we can track enrollments and projects through the semester. I added support for meeting drafts, so you can make a meeting and then you don't have to publish it until you're ready to, so that's nice. I squashed a bunch of bugs. The Discord bot is new, and it supports slash commands, which are also new. And then I've made a few changes to the user profile page to display a history of meetings that users have hosted. So this is what the semester interface looks like. So this is actually real data. This is what's in the database right now. And then this is the meeting creation form that I worked on this semester. This is just the upper half of it actually, because it's a pretty long form, but so I'm proud of this too. The Discord bot works. You can use in the RCOS Discord right now if you want. You can go into a channel and use /whois, and it will look up to see if that user is in the RCOS database, and then we'll get you a link to their Telescope profile. And if they have RPI cast linked, it will get you their RPI email as well. So that's pretty cool. Telescope is written using Rust and the Actix web framework. It also uses the Handlebars templating engine, Bootstrap for CSS to make everything pretty, and jQuery for a bit of interactivity. Telescope 6.4 is live here at telescope.arcos.io. We have a channel on Discord that you can join that I watch for feedback, although if you DM me, I'll also see that too. And you can also make issues on GitHub on our repo linked here. The future for Telescope and the rest of RCOS infrastructure is hopefully a long one. I'm going to continue working on and deploying new versions of Telescope and new features throughout the fall semester. I'm graduating in December, so I hope to have a 1.0 released by then. And I'd love to have a team of developers help me achieve that this fall. So if any of you were sticking around for the fall semester, I'd be really happy to have you. It's also important that we get younger RCOSers, younger RCOS members to know about Telescope, to use Telescope, and if we can, to know kind of the ins and outs of Telescope so that, you know, if there's a bug down the road, you know, years after I've graduated, I'm not the only one who knows how to fix it. The database, API, and handbook are all relatively stable. They don't change much at this point, but, you know, happy to have anyone who wants to get involved in those do that too. We plan to basically just solidify their existence through connecting them to each other, connecting them to Telescope, and making sure that all of the old data that's in Observatory gets put in the new database now so that it's available through Telescope and we don't have to keep running Observatory and deal with that anymore after, you know, the end of the fall semester. So that also includes documenting their existence and educating, as I said, the next generation of RCOS leadership. That's all from me. Any questions or comments? Yes. So, sorry, can you repeat more?
I guess all the words aside, how do you have a plan for actually integrating it with like more than just the coordinators and counselors?
Yeah. Well, currently it's public, actually. Anyone can go to Telescope and use it right now. A lot of the features.
Whoa.
Yeah.
That.
A lot of the features are not currently, you know, I have access pretty limited to just the people who are already in the database at the moment. hard to edit anything because we don't yet support enrollment data through Telescope, which we do in the database, and so that's going to be what I work on this fall. But yeah, we already have a bunch of this all public.
But it's only A's.
Oh yeah, you can, if you go to the top.
We need more than A's.
There's,
Oh, there we go.
There you go.
Okay. Because I'm like a W or a T. I always like to see myself on these things.
You can also, you should be able to type your name into the search bar.
Nah, that's too hard.
Oh, there you go.
So just for those of you who aren't aware, Nia did a demo of this just a little while ago, and it didn't look anything like this.
It's changed a lot this semester.
So this is really cool. This almost looks like we stop using RCOS.io and start pointing people here. Which, I guess that's actually a question.
That's definitely something we could explore.
Okay. That sounds like yes. I'm just telling you, everybody else says we're not ready. You said it's something we can explore. That is so far beyond we're not ready that sounds almost like a yes.
I would say that the only thing that RCOS.io can do that this cannot currently is attendance codes. We don't support those yet.
Okay. We've got workarounds for attendance codes. Venue and submittee. I mean, I would love to do attendance codes through this as well, but wow, this looks really nice. Yeah, so just to let you guys know, this is probably going to be the main front page for RCOS going forward fairly soon.
Check out the meetings tabs. This meeting is already there too, which is cool. It's even color coded.
At some point, I will get a password for something. I'm not ready for that yet. It's just so you know, that's not a push on you. That's a when I'm ready, I will ask. Until then, I am perfectly happy to sit here and watch. So anyway, this is something that's been going on for a while. If you're planning on rejoining RCOS in the fall or even in the spring, we're gonna need bridging between the fall and the spring. I don't want to lose Nia and have a semester of no support as we come up to speed. So we will be pressuring some of you to join Nia on Telescope in the fall. Nia is not too badly of a slave driver, I don't think. She's pretty good to work with. But it is important that we get some people up that understand this who are in our meetings in case something goes horribly wrong. So and we will be unless she can convince me that she's not ready, I think we switch over for fall semester, and we make this not just telescope.arcos.io, but arcos.io, and the other one becomes old.arcos.io or something. So cool. Very nicely done. We've been waiting for this. For those of you who don't know the history, not all software projects are successful. We had three previous versions of observatory upgrades that didn't make it. This one looks like it's made it, at least close enough that there are probably no greater bugs in this than there are in the current one, which is slowly falling apart as all the bits get eaten by digital bacteria or whatever it is that causes code to decay. Anyway, enough babbling. It's been a great semester. Thank you all for your patience as we kind of navigated this hybrid semester. We are back in the fall in just a little over a week. The coordinators and Professor Makis and myself will be going over this weekend. We're hoping to get all the grades done. My hope is to have them done and entered by Monday afternoon at the latest. Hopefully, even before that. Get your final commits in, and we will, and then take, I call it aggressive relaxation. You'll have about 7 days to 10 days to aggressively relax. So don't waste it on sleeping, unless you need to. I slept 17 hours after my last final one semester. Anyway, we will see you, most of you in the fall. We'll see the rest of you in the spring, for those of you who are on your way semester. It has really been fun. This is a fun class. I really love sitting here and looking at all the presentations. And I hope you've had fun as well, and we'll get you some grades out as quickly as we can. Any questions, anything else before we kind of call this a done deal? And Hunter, if you're on and you can see the chat, I can't currently see the chat because that box is sitting on a different place. So, yeah. Oh, you were gonna read off any comments that came up, like what am I doing? But I've got the chat up now, so we're okay. Okay, thank you all. I'm gonna shut down the record. Actually, I'm gonna shut down the recording because it's unnecessary. But